This is part 3 of Engineering Mathematics and Modeling Week 3. And we've just discussed determinants and how to calculate them. And now we're going to use them to calculate the inverse of a matrix. Matrices can be seen as, well, linear transformations. They can be used in all kinds of equations. And sometimes it's useful to be able to calculate its inverse. I will put some links either in the description or on Brightspace to a video of a very nice YouTube channel, 3 brown, 1 blue, which describes the use of a matrix as a linear transformation. And you can imagine if we can transform a vector from, well, essentially one space to the other, we might also want to transform it back, and that is what the inverse of a matrix can do, similar to the inverse of a function. So, we can only calculate the inverse for a matrix which is square. So we'll assume that A is n by n. Now, the inverse of a matrix A, denoted by A to the power of -1, is an n by n matrix for which, if we multiply A times A inverse, we get the n by n identity matrix. And of course, A inverse times A will also yield the n by n identity matrix. And remember that the identity matrix is a matrix with 1 on the diagonals and 0 everywhere else. This is a quick representation of just 1 on the diagonals and 0 everywhere else. A has an inverse is equivalent to the determinant of A being non-zero. So if the determinant of A is 0, A will not have an inverse, and if it is not equal to 0, it will have an inverse. Now, again, for the 2 by 2 case, just like the determinants, we can write out the inverse fairly easily. So if we have a matrix A, B, C, D, the inverse of A, assuming, of course, that its determinant is not equal to 0, is given by 1 over the determinant of A, and remember the determinant of A is a number, times dA minus B minus C. So for any 2 by 2 matrix, we're able to calculate the inverse. So if we have an example, 3, 4, 2, 6, so this is our matrix A. Well, can we calculate its inverse? Well, let's determine its determinant first. The determinant of A is equal to 3 times 6 minus 4 times 2. So that is 18 minus 8 is equal to 10. Now we can write out its inverse then. A inverse is equal to 1 over 10 times, well, these elements switch around, 6, 3, minus 4, minus 2. And we have the inverse of a 2 by 2 matrix. Now, for the general case, I will write the general case out here, and then I will pause this video and clean the board. So for the general case, suppose that the determinant of A is not equal to 0. If this is the case, it has an inverse. If it is equal to 0, we can stop here. So step 1 is determine the transposed matrix of A. We know how to calculate the transpose, basically turning every row into a column. 2, replace each element of A transposed by its cofactor. And that yields a certain matrix. The result is the adjoint matrix of A. So we calculate, so we calculate the transposed of that matrix. We take each element. So for a 3 by 3 matrix, we have 9 cofactors to determine. We know what a cofactor is. It is a plus or a minus sign times a 2 by 2 determinant. And the resulting matrix is the adjoint matrix of A. And then to find the inverse of the matrix, that is 1 over the determinant of A times the adjoint matrix of A. Now, finding the determinant of A is the first step, because if it's 0, we can stop. So we will have found the determinant beforehand. The adjoint matrix is where all the work is, and in the next video, or maybe I'll stick these two on, I will show you how you can calculate the adjoint matrix of a matrix A. But I'll need a bit more space of this. I'll also just quickly show that the cofactor of element ij is equal to minus 1 to the power of I plus j times the minor of iaj, and we know that the minor, let's say we have a11, a12, a13, a21, a22, a23, a31, a32, a33. If this is our matrix A, then the minor of, for example, a21, so this element we get by removing row 2, column 1, and we are left with a 2 by 2 determinant a12, a13, a32, and a33. And we know how to calculate the 2 by 2 determinant. So these are the steps and the ingredients, and let's see how that works for an example of a 3 by 3 matrix.